Lucas opens a bank account with 1,000 and lets it accumulate at an annual nominal interest rate 6%, convertible semi-annually. Danielle also opens a bank account with 1,000 at the same time as Lucas, but it grows at an annual nominal interest rate 3%, convertible monthly. For each account, interest is credited only at the end of each interest conversion period. Calculate the number of months required for the amount in Lucas's account to be at least double the amount in Danielle's account. So we'll first find the amount equations for both the persons. For Lucas, it's semi-annual compounding. And now we know that in general, the amount function equals principal times 1 plus im by m raised to power mt. For Lucas, m is equal to 2 because it's semi-annual compounding, and the nominal rate is 6%. So I superscript 2 is equal to 0.06. So after t years, the balance of Lucas it's trying to put a space here. Okay, so after t years, Lucas's balance is 1,000 is the principal, 1 plus 0.06 by 2 power 2t equals 1,000, 1.03 power 2t. For Danielle, the compounding is monthly, so m is equal to 12, and her nominal rate was 3%, so I superscript 12 is 0.03. After t years, her balance is 1,000 times 1 plus 0.03 by 12 raised to power 12t equals 1,000 times 1.0025 power 12t. And now we're looking for Lucas's amount to be at least double of Danielle's amount. So they start the same. Lucas obviously has a better interest rate, so his amount is growing faster. So at some point, it's going to be double of Danielle's amount. And we have to find the number of months in which it happens. So we first set Lucas's balance equal to twice Danielle's to see what's going on. So Lucas was 1,000 times 1.03 power 2t equals twice of Danielle's. So Danielle's was 1,000 times this. So twice of this means 2,000 times 1.0025 power, not 144k, but 12k, 12t. 12t. Okay, and now we divide both sides by 1,000, and then we take ln of both sides, and on the right side, this is a product, so it breaks into ln of 2 plus ln of the other quantity, and then we use the power rule of log. So this is 2t ln 1.03 equals ln 2 plus this would be 12t ln 1.0025. And then we calculate ln 1.03 multiply by 2, and we get 0.05912. Similarly here, we find the value of ln 2, and here we find ln 1.0025 and multiply it by 12. And then we combine the two t terms by bringing this one over left and subtracting. And finally, we get t is 23.77 years. So we multiply it by 12 to get 285.3 months. Now, the thing over here is that they are telling us that interest is credited only at the end of each conversion period. So for Lucas, the conversion period is 6 months, every 6 months, semi-annual. And for Danielle, it's every month. So in fact, this is telling us that if the interest was being credited all the time and not just at the end of each period, then it would be 285.3 months when Lucas, his balance would be double of Danielle's. However, the reality is that So basically, any time less than 285.3 months, Lucas's balance is still not double of Daniel's, it's still short of that. So in particular, remember that since Lucas is being credited only after every 6 months period, so we have to look for multiples of 6 in months. So the multiple of 6 before 285.3 is 282. So at that time, that was 282. So before 285.3 months, the last time Lucas's amount increased was 282 months, because 282 is a multiple of 6. So obviously by that time, his account has not been double of Daniel yet. So the only time it could be, so it becomes double from 285.3 months onwards in theory, if it was continuous compounding. So what we have to look for is the next multiple of 6. So obviously any time after 285.3 months when Lucas gains a new balance because of the balance being changed only at the end of the 6 months, then he'll be more than double of Daniel, but not before that. So the next multiple of 6 after 285.3 months is 288 months. So by that time, his balance will overtake twice of Danielle's. But as we discussed before, in the previous 6 months period at 282 months, it hasn't yet happened. So 288 months is the minimum number of months in this scenario that Lucas would be at least double. So now let's suppose that we didn't have this condition that account was being credited only at the end of each conversion period. So then the answer, let's say it's credited at the end of each month. So in that case, it would be the next month after 285.3 and be 286 months. And if it was being continuously credited, then it would be 285.3 months. So now, with the given condition, since it doesn't happen at 282, and it happens at every time after 285.3, at every valid time after 285.3, the next valid time after 282 is 288, which is bigger than 285.3. So 288, his balance is at least double. In fact, it would be more than double by that time, but that's the minimum number of months at which it will happen. So the correct answer is 288 months, and that was choice E.